Hi, here's the charger for the Retevis RT3 DMR transceiver, and this is the output voltage of the charger. There are two lithium-ion cells inside the transceiver in the battery. So it means each one gets 4.3 volts. It's a bit too much for my liking. Actually, it should be 4.2 volts maximum, so 8.4 volts output of the charger, but I think I will make it 8.3 volts just to be safe. So let's open it and see what's inside. Okay, so here's the board, here's the LED. This is a comparator. I will show you some close-ups in a moment. This is a buck regulator. It's called MC34063. It's a standard buck regulator, and some feedback resistors for it are here, and we'll need to modify them. Let me zoom down. Okay, some macro shots. This is the buck regulator chip. Those are those feedback resistors, and this is something comparator. It's only used most probably it's only used to measure the current and switch this LED from red to green when it's charged. So let's do some calculations with those resistors first. Or actually, you know what, let's see the datasheet first. This is the datasheet for this chip. You can see that it has comparator input here. This is the 5th pin, and there was a schematic somewhere here. Yeah, this is a recommended schematic, and you can see that input of the comparator goes to the output of the chip via one resistor and to the ground via another resistor. So it's a resistive divider, and in this case this is R4, which goes to the output, and it's 10K. And this is our R3A and R3B. R3A is 33K and R3B is 1K8, or the opposite, I don't remember because I made some notes first, but it doesn't matter. And let's see the input. Oh my god, sorry. The input voltage. There was a table somewhere here. Yeah. Threshold voltage. It's called comparator threshold voltage, 1.25 volts. So when it's 1.25 there, it stops. Well, it's a feedback. I don't know if it just stops converting for a moment, or this is the duty cycle, because you know those schematics can be sometimes very misleading. Okay, so let's calculate the equivalent resistance of those two this is a hard word for me, for a Polish guy, to parallelly connected resistors. Okay, so we have 33K, we'll calculate in kilo ohms, times 1.8 and divided by the sum. 1.8. 1.707, I think we can assume. So let's write it down somewhere here. Yeah, I know I will need to take some notes. Yeah, but you know, I want to show you the process of determining the value. So R4 was 10K. This is to the output, and R3 is 1.70, I don't know, 707. Okay, and now let's calculate the output voltage, just to be sure if we got it right. So I do it from something called proportions. I don't know if it's called this way in English. So V output is proportional to 10K plus 1.707K. It's in kilo ohms, and 1.25 volts, because this was a threshold voltage, is only proportional to 1.707K. Why? Because you know, you can think of it like like this, and this is the feedback 1.25, and this is the output voltage. Okay, so now let's calculate. So V out times 1.707 kilo ohms is 1.25 volts times 11.707 kilo ohms. So now I can calculate V out. It's 1.25 volts times 11.707 kilo ohms divided by 1.707 kilo ohms. So V out right now is, let's calculate it. The light is great, as always. 1.25 times it's somewhere, I don't know how much did we measure, of course, but it's something like this, 8.573. Okay, so now let's calculate. Okay, I will want to add some resistance in parallel to R4. So let's first calculate our desired R4. By the way, you can skip all this math if you're not interested in how to do it, but you just want the value. Okay, so our new V out will be, I don't know, let's use 8.3 volts. Okay, and now the same formula. Okay, so V out times this resistance is equal to 1.25 volts, because this is the threshold voltage, times and this is our R. This is the equivalent R4, let's call it R4 prim, plus 1707 kilo ohms. Yeah, so we can calculate this. Okay, click on this. So V out times 1.707k is 1.25 volts R4 prim plus 1.25 volts times 1.707k, and this is a constant that will be calculated. Actually, I can use not V out but 8.3 from now on. So we can use 1.25 volts times R4 prim is equal to this value minus this value, right? It will be this way. So it's 8.3 volts times 1.707k minus 1.25 volts times 1.707k. So R4 prim formula is 8.3 volts minus 1.25 volts times 1.707k divided by 1.25 volts, and let's use the calculator and calculate it. So it will be 8.3 minus 1.25 times 1.707 divided by 1.25. It's now 9, seems reasonable value. 9.62748. Let's not be that precise, so it's 9.63. It will be enough. Okay, so now we have 9.63 and we need to calculate the value. So we have two resistors in parallel, right? This is R4 prime, which was 963, right? Okay, and R4 10K, R4B, let's call it, is what we're looking for. So it's 10K times our R divided by 10K plus R is 9.63K. Okay, I took the light out. So we can do like we did at school. So multiply by 10K plus R both sides. So this will be just 10K times R, and this will be 9.63K times 10K plus 9.6, you cannot see anything, 9.63K times R. Okay, I don't know if you can see anything. Yeah, you can. So we have 10K times R. We can do just minus 963 times R is 963 times 10K. So 10K minus 963K times R is 963 times 10K, 963K. Yeah, units are important because you know they serve us as checking. For example, now we can check that this is in kilo ohms, this is in kilo ohms, so we have kilo ohms squared. This is in kilo ohms and this is in kilo ohms, so we'll have kilo ohms squared on both sides. So let's calculate 10 minus 9.63. So it's 0.37K times R is 963 times 10K, 96 and 3K squared actually here. So R is 96.3K squared divided by 0.37K. I say K, but I mean kilo ohms, and I know what I mean, so I'm not writing ohms. So, but you know, let's divide it. It's around 260 kilo ohms. Let's write those ohms here. So we need a resistor around 260 kilo ohms parallel to R4 on this board. So here's my box with resistors, SMD resistors. Well, I have 270K, 270K kilo ohms. Let's do the math once again to see what will happen if I use this resistor. So once again, R4 is 10K, R4B is 270K. Where's my phone? I lost my phone. One moment, I have to unlock it. So 10K times divided 9,643. So R4 prime is 9,643K. So again, let's use the this formula so you remember it. So V out is proportional to 9.643 K plus 1.707 K, and the feedback voltage is proportional to only this lower resistor 707 K. This is R3A and R3B in parallel. So V out times 1707 K is 1.25 volts times 9 plus 1.707 K. So V out, our new V out is this times 9643 K plus 1.707 K divided by 1.707 K, which is, let's calculate, 1.25 times 9643 plus 1707 divided by 1707, 831 volts. 831 volts, which is 4.15 or 4.16 actually volts per cell, which will be perfect. So let's try. And actually it's quite challenging for me to do on camera because I use a different light. When I solder, I put the board in a different place. Yeah, so this is my new resistor, and those tweezers are already magnetic. They shouldn't be magnetic. Maybe I should demagnetize them or buy a new one. A pair. Is it a pair or is it? Well, it's not a tweezer, but tweezers, so probably a pair. I will have to check. Let's scroll in the soldering tip a little. Probably it looks horrible on camera because I don't see what I'm doing. But okay, maybe it will be good enough. Now I need to put it a little closer. I need to put the resistor a little closer to this one. Well, I don't know if it's soldered. I will test it. No, it's not. Okay, this is horrible. Whew, wow. No, I shouldn't solder it on camera because I don't see what I'm doing, you know. But, well, maybe it's somewhat soldered. It doesn't have to look perfect, it just has to work well. Okay. Did you see anything? I don't know. Anyway, let's connect it now and see the output voltage, which, by the way, is here is one pin and this is another pin. So we can just do it this way. Connect the power supply to it. Voltmeter. Disable those horrible lights, of course. Conditions here aren't great, and here's the moment of truth. I want you to see everything. 8.3 volts. Was it the voltage that we wanted? Yeah, probably. I don't remember the exact value that we want. Is it here? 831. So the charger is done. I will inspect it under the microscope or just with a loupe. This is my soldering to see if it's soldered well, because, you know, on camera it's different on camera and different when I do it. Alright, so the charger is done, and thanks for watching.